All right, in this lesson, we're looking at relative frequency. Now, we're used to talking about theoretical probability, but in this case, we're looking at past history and using that to determine something in the future. So, for example, the weather, right? We could say that in the last 7 days that it's going to rain. It's rained every 7 days, so the probability of it raining tomorrow is probably that it's going to rain, okay? Doesn't necessarily mean it's going to happen, but it means looking at past what might happen in the future. So let's have a look at this. So I've got a 6-sided dice, nice and easy, and I've rolled it 60 times. Okay, so our total down here is 60. And you'd expect with 6 sides that everything would come up about evenly, right? It's a perfectly unbiased die. It's not weighted on one side, but you would expect that everything comes up 10 times to get our 60. But if you have a look here, that's not what happened. Okay, you can flip a coin, say, and you know that it's 50-50 heads or tails, but you could flip it over and over and over and get 10 heads in a row. Okay, and same things happen here. So we've got some that have got quite a few, some that have got not very many, even though you would expect they would all come up the same, but they haven't. So we're going to use that and to calculate the relative frequency or the probability that something's going to happen. So I've probably written these incorrectly, and I should have written RF for relative frequency, but that's what we're finding today. And that's the number of successful trials of the thing we're looking for divided by the total number of trials. In our instance, we've got 60 trials, and we are saying, all right, what's the probability of getting a 1? So the probability of getting a 1 would be the number of successful trials that we've had, and that would be 10. We have had 10 over here, if we just have a look here, and we have a total of 60. So then if we simplified that down, you would have 1 out of 6. Now let's find the probability of getting an even number. Now an even number in this case would be the probability or the relative frequency of getting a 2, a 4, or a 6. So we have to look and add them all up. So we've got 2 here, 2 got 2. We have to add in the 18 for the 4 and add in the 11 out of our 60 there. So we've had to add up all the possibilities that they were correct in the trial. So what have we got? 2 plus 18 is 20, so we've actually got 31 here. So it would be 31 out of 60 there. Okay, now we're looking for the probability, and we'll move this across here, of not getting a 4. So that's every other option. So it'll be the probability of getting a 1, a 2, a 3, a 5, and a 6. So in this case, we have to do what we did last time, and we have to add them all together. So we would be looking at the 10, the 2, oops, sorry, I need to add in a 2 plus a 15 plus the 4 plus, did it again. We have to add all these plus the 11 and all of that divided by a total of 60. So we can do that on our calculator later on. And we're looking at now the probability of getting a number over 3. Remember, that does not include 3. Okay, 3 is not bigger than 3. So in this case, we'd have to identify all of the successful trials that fit that condition over 3. And we know that that would be the 4, the 5, and the 6. So they would be the ones we'd be adding together. So we're looking at 18 plus 4 plus 11, all over 60 there, and you can finish that off on your calculator and get it to its simplest form. All right, so relative frequency is like looking at theoretical probability, but in actual fact using our past history data to find out what will happen next.